In this first part of 2.1, we're going to be talking about different types of relations and functions and kind of defining the different categories and explaining what the difference between them are. So there's this little area right here. We're going to define 3 different types of functions, or I guess really 2. You can be one-to-one, you can be on-to, or you can combine them and you can be both. So you should have this written in your vocabulary, but what it means to be one-to-one means that each element of the domain goes to exactly one unique element of the range. So that's what you should have in your vocabulary. Let me show you what that looks like. So let's do domain and range. Let's say we've got 1, 2, and 3. Those are elements of our domain. And then let's do A, B, C, and D as elements of our range. Okay, so here's how the mapping is going to go. Let's say 1 gets mapped to D, 2 gets mapped to B, and 3 gets mapped to A. So this is a one-to-one function. It has nothing to do with the fact that the C is missing. What's important here is that A only got mapped by the 3, and B only got mapped by the 2, and D only got mapped by the 1. So one-to-one means everyone in the domain only gets paired with one element in the range, and each of the elements in the range only came from one element in the domain. Because remember, it is possible that like 1 could map to D and 2 could map to D, but that wouldn't be one-to-one. Okay, next category is onto. What onto means that each element of the range is mapped from some sort of element in the domain. So let's do something slightly different here. Let's say 1, 2, 3, 4. And then for range, we'll just do ABC. Okay, so say this is the mapping. Let's say 1 goes to A, 2 goes to B, let's say 3 also goes to B, and 4 goes to C. Okay, so what it means to be onto is that everything in the range got hit. A, B, and C got hit by different elements of the domain. Okay, so let's compare and contrast these real quick. This picture right here is not onto because the C did not get hit. So every element of the range did not get hit. This one is not one-to-one because the B gets hit twice. So this one's one-to-one because each one only gets hit a maximum of 1 time, and this one's onto because they all get hit. All right? Now both means they all get hit exactly 1 time. They all get hit, that's what makes it onto, but they each only get hit once, and that's what makes it one-to-one. So let's do something like this, 1, 2, 3. And then the way the pairing works out, that doesn't matter. So like let's say 1 goes to B, and 2 goes to C, and 3 goes to A. So again, this is one-to-one, because there's only a one-to-one pairing here. These only got matched by 1, not 2. And then onto means every single one of them got hit by an element of the domain. So that's what those 3 definitions mean. Let's see which we've got covered here. So for both of these, we want to state the domain and range. And remember, domain is all the possible x values, range is all the possible y values. So let's start with that. So this is a set of ordered pairs. So let's start with the domain. Domain is all of the x values that get hit. So I'm just going to move from left to right. So like this is the first one, and this is an x value of -1, 2, 3. So -3 gets hit. These points are both at -2 for an x value. This point's at -1. This point right here is at 0. This point is at 1, and then we have 3, and then 4. So those are all our possible x values. So if you were to look at the coordinate points, I just listed all the different x values. But remember, you don't list them twice. And then range is my y values. So this is my lowest y value, and that's a -3. These are both at a -2. These are both at 1, these are both at 2, and then this one's at 4. Okay, so those are all the possible y values that were covered. Then determine whether each relation is a function. So remember what it means to be a function. Now this is super, super important. What it means to be a function is that each element in the domain only goes to one element in the range. So we've got a couple of little issues here. This set of points is an issue, because our x value is -2 and it's getting mapped to 2 different values. That can't happen. So this is not a function. Now you may be wondering if these 2 points are okay because they have the same y value, or these two, and that's actually fine. Here's an example I want you to keep in mind. Say that I went all the way around the room and I got all of your heights. It's definitely possible that 2 of you could have the same height. That's what's happening here. 2 different x values have the same height or y value. Same thing here, same thing here. But this is basically the same as saying that one person has 2 different heights. That's not a thing. That's not possible. One person only has 1 height, but it is possible that 2 people have the same height. So that's the difference here. These are like the people, and these are like the heights. So each person only has 1 height, but it's possible that 2 people get mapped to the same height. So that's what it means to be a function. These points right here are the reason why this is not a function. And then if it is a function, answer a further question. Since it's not a function, we're not going to answer that last question. Okay, now domain and range. We don't need to state the domain and range again. The domain are these 5 values right here, and the range are these 5 values right here. Let's talk about the function thing. So all of these x values, see how they all only go to 1 value of the range? So it's like each person having their own unique height. So this is a function. And then because it's a function, now we can answer this question. So let's determine if it's 1-to-1. So does each value in the range only get hit once? Yes, 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 no. The 6 gets hit twice. So it is not 1-to-1. Now let's see if it's onto. Onto means every single value gets hit at least once. Yes, 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 no. The 8 doesn't get hit. So because the 6 gets hit twice, it's not 1-to-1, and because the 8 doesn't get hit at all, it's not onto. So this is actually neither. Okay, let's look at the next example that we have. This is going to describe the vertical line test, and the vertical line test helps us to figure out whether something is or is not a function. And it's pretty simple. It is, if you're looking at a graph, you want to see if something passes the vertical line test. So let me show you 2 different examples. So I'm going to show you what it looks like to pass the vertical line test, and I'm going to show you what it looks like to fail the vertical line test. So let's take a graph that looks like this. This is called the parabola. We'll do more with it in later years or later chapters. A vertical line looks like this. So if you can pass a vertical line through the graph and it only passes at 1 point, that's passing the vertical line test. It's like this vertical line would only cross the graph once. This vertical line would only cross the graph once. And what these vertical lines represent are different x values. So it's saying for this x value, I only have 1 y value. For this x value, I only have 1 y value. Now a graph that doesn't pass the vertical line test could be something like this. This fails because if you were to draw a vertical line, it would hit in 2 different points. And that means that this x value has 2 different y values. So that's why it doesn't pass. Let's look at this last example here. Average fuel efficiency for SUVs given by these values right here. Graph this information and determine whether it represents a function. Okay, so we are going to set up a little scatter plot here. So this is going to be the years, and then this is going to represent the fuel efficiency. Okay, so from 2001 to 2007. So 2001, 2, 3, 4, 5, 6, 7. Okay, so from 2001 to 2007, and then these are all the values. Okay, so the lowest is 20.6, and it looks like the highest is 22.6. So let's make this 20, make this 21, 22, and 23. So this is just going to be a little bit of practice in plotting ordered pairs. So in 2001, it was 20.8. So 20.8 would be pretty close to 21. 2002, the next one is 20.6. So close to this one, but just a little lower. The next one is back to 20.8. So this x value has the same y value as this one does. 20.9, really close, just a little bit higher. Next one is 21.6, so this is going to be almost to 22, halfway I guess. 22.3, maybe right about there, and then 22.6, maybe right there. So that is what our fuel efficiency looks like. As you can see, it's kind of going up. So let's answer a couple questions here. Graph this information and determine whether it represents a function. Well, it would pass the vertical line test. There aren't any points that are right on top of each other. So yes, it represents a function. And then is the relation discrete or continuous? Remember, continuous means you could draw the whole thing without lifting your pencil. This is discrete because it's actually just a finite set of points. So if you're literally looking at a number of points, it's discrete. If you're looking at like a smooth function like this, that would be continuous. All right, so we'll pick up with the other half in the next video. Okay, so now we're going to look at some functions that are defined by an equation. So like something like this, like when we tell you to graph an equation like this or like this, rather than a set of ordered pairs or a graph that's already in front of you or something like that. So first one, we've got y equals 3x minus 1. So we're going to be graphing these. And we haven't really done a ton of work with these graphs, so we're going to graph them both by using a table. So anything you see in this section, you're going to make a table to graph them. So a pretty classic go-to table is from -3 to +3. That hits a little bit of everything. Okay, so those are your x values. So your x values are your independent variables. Those are the ones you choose. Those are the ones you plug in. Once you plug them in, they go in for this x right here. So if we plug in 3 times -3, that's -9, and then -1 would be -10. And then we just go down the line, we do the same thing. So plug in the -2, 3 times -2 is -6, -1 is -7. Plug in the -1, 3 times -1 is -3, -1 is -4. Plug in 0 is easy. 3 times 0 is 0, -1. 3 times 1, -1 is 2. 3 times 2 is 6, -1 is 5. And 3 times 3 is 9, -1 is 8. So these are a whole bunch of points that are going to get plotted when we graph this function. Okay, so we're going to graph it. I'm going to graph it kind of right in the middle here. Remember, we've still got plenty of space that we need to reserve for all those questions that were being asked. Okay, so these are my x values, these are my y values. Pay attention to the values that you have so you know how to scale it, if at all. So we've got 1, 2, 3, -1, -2, -3, and then we need to go all the way down to -10, all the way up to 8. So we're going to scale this a little bit. So each of these ticks is going to represent 2. So -2, 4, 6, 8, 10, and then up 2, 4, 6, 8. You can scale the y-axis differently than you scale the x-axis, but like you couldn't scale the bottom half of the y-axis different from the top half of the y-axis. All of the y's have to be the same. All of the x's have to be scaled the same, but they can be scaled differently, if that makes sense. So let's plot these points. So we have the point -3, -10. So -3, go down here to -10. -2, -7. -1, -4. 0, -1, 1, 2, 2, 5, and 3, 8. Okay, so those are all the points. Now, this actually ends up being a continuous function. Anytime you're graphing an equation, it will always be a continuous function. These are just points that we chose. We could have plotted an infinite number of points. We could have plugged in, 1.1, 1.2, 1.3. We could have plotted technically every single point. So what ended up happening is you'd fill in an infinite number of points in between each of these points, and that turns just into a line. Okay, so our equation ends up being a line. Remember, there are technically an infinite number of points, way more than just the points that I chose to plot right here. Okay, so now let's answer this. Is the function 1-to-1? Every x goes with one y, so yes, 1-to-1, there is a 1-to-1 correspondence between x and y values. So 1-to-1 is a yes. Onto, does the entire range get covered? All my y values end up getting covered, yes. So this is 1-to-1, it's onto, so we would say that this is both. So it is both 1-to-1 and onto, and then I just told you guys that it is continuous. So anytime that you're given an equation, rather than just a discrete set of ordered pairs, it's always going to be continuous. Now, let's determine the domain and range. That's a super important thing that we're going to start working with. Domain and range is going to take us throughout the entire year. We're going to make sure we know how to find the domain and range for any function that you're dealing with. Okay, so domain. Domain is all the possible x values. It's what you're allowed to plug in. Okay, so what we do is we're just going to use D and R, kind of keep it simple for domain and range. So domain is what x values you're allowed to plug in. If you look at this equation right here, you could plug in anything you want. Positive numbers, negative numbers, 0, decimals if you want, fractions if you want. You could plug in anything you want and any x value would be possible. Okay, so that means that our domain is all reals. So we've got this little, this is just the symbol for all reals, that little double block R. So we've got all reals, which means literally any x value could work. Okay, now let's talk about the y values. The range, now we're assuming when I draw these arrows that the graph could go on forever. This is just a little piece of the graph. But when if I go up forever, down forever, in terms of y values, I will also eventually hit every possible y value. It'll keep going up forever, it'll keep going down forever. Every y value will eventually get hit. And so that means my range is all reals as well. So this means every single x value can get hit, every single y value will get hit. Domain and range are both all reals. Okay, let's look at another one. X squared plus 1, we're throwing an exponent in there. So same table, same x values. Now be careful when exponents come into play, because I'm taking a -3 and I'm squaring it. So -3 times -3 is +9, and then I add 1. So that would come out as 10. If I square -2, I come up with +4 plus 1 is 5. -1 squared is 1, plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. And 3 squared is 9, plus 1 is 10. So I've got all these values. Again, remember when you graph your function, make sure you're paying attention to what values need to be hit. So I need this range of x values. And then notice here there are no negative y values. So I don't actually really need to graph any negative y values at all. Just the positive y values. So x values, y values. So x, I've got 1, 2, 3, -1, -2, -3. And then I'm going to scale this again because I need to go up to 10. So 2, 4, 6, 8, 10. All right, let's plot our points. So -3, we're up here at 10. -2, we're at 5. -1, 2. 0, 1. And then we actually repeat the same points back here on the other side. Okay, so you see these points? This ends up being a shape that we call a parabola. I'm sure you guys have heard of that before. So we plot these, a parabola is like an arc sort of shape. So it looks like that. All right, so that's the graph. Again, just based off the equation, we plotted some points and that's what it looks like. Let's answer all these questions. Okay, so let's start with the domain and range. So domain, range. Remember, domain represents what x values you're allowed to plug in. So look at the equation. There are no restrictions. You could plug in any x value that you want. Positives, negatives, decimals, fractions, whatever. So the domain, again, is all reals because you're allowed to plug in any x value that you want. And then the range represents the resulting y values. So picture if you were to plug an infinite number of points in, if this graph were to go on forever, what y values are getting hit. So if you look at this, see these arrows went up forever, down forever. These arrows go up forever. They don't go down forever. This is the lowest possible y value that you will ever hit. Even if you graph this for an infinite amount of time, you're never going to go any lower than this. So this lowest possible y value is 1. You never hit a lower y value. None of this ever gets covered. So we write it like this. Only y values that are above 1 will end up getting hit. 1 is the lowest possible, and then it only goes up from there. Okay, let's answer these questions. Is it 1-to-1? No, it is not 1-to-1. Look at the table. We've got 2 different x values corresponding to the same y value. So no, it is not 1-to-1. It is onto. The entire range gets covered. Here's the range. We cover every single value that's bigger than 1. So it's not 1-to-1, but it is onto. And I told you in this section, every single thing that you see is going to be continuous. All right, quick little thing with function notation. Function notation looks like this. For example, the last graph that we saw was x squared plus 1. So this is just an example. This is what we mean by function notation. We write f of x or g of x or h of x or whatever. And the way the notation works is whatever you see in parentheses is what you want to plug in for the variable. So this function notation, when I write g of -2, it means, like, see how I have an x here and then I have an x here? Whatever you replace this x with, you replace this x with. So g of -2, that means you're using this function, but you're replacing the x with a -2, like this. And then you simplify it up as much as you possibly can. So -2, when I cube that, I get -8 and then -3. So that would leave me with a -11. So that's the function g with -2 plugged in. So now let's throw in a variable here, g of 2t. So that just means, again, if I replace this x with a 2t, that means I replace this x with 2t. Okay, so be careful here. That whole thing is in parentheses and it's all being cubed. So make sure the 2 is cubed and the t is cubed. So 2 cubed is 8 and then t cubed. And then -3. These are not like variable parts, so I can't combine them any farther than that. I just call that expression my final answer.